Hello again. We're taking a look today at the performance of a generator that we built, and it's a good performing generator, but it may actually need to be tuned a little better. And I'm going on the advice of my friend Dan Bartman, the guy that wrote this book, and he tells us that the hole in the coil should be about the size of the magnet. Now, I know you can't see this particular generator, but the magnets are much bigger than the actual coils, so if you looked at the waveform that this generator makes, it's kind of clipped off at the top, kind of flattened out. See it? Not really what we want. We'd like to see something that's nice and round on both sides, a good AC waveform. So, you know, the advantage of this particular generator setup is that you can configure it for all different tests, and it doesn't require any really difficult modification. So here's one. This particular one, if you look at it, we're only using, we got two bearings out here. We got an extra bay here, and the rotor is sitting in status somewhere in the middle. Okay, I put together another rig with a set of coils that I've been talking to Dan about. So check this out. This doesn't look like what you'd expect to see for this generator, but this. Okay, so I'm just going to take the rotor off. Wasn't that easy? I just took it off with my hand. That's what the coils look like on this one. Okay, and so here's my magnets, right? And I literally just stuck them on the plate. I'm not going to go very fast with it, so I can literally take a magnet off, and you can see how that magnet kind of fits in the hole. It's probably a little big for this setup, but it does fit. Oops, be careful with these magnets. And they're double stacked neo magnets. So again, I got to get my polarity right. It's south-north. Okay, so, and that's it. That's all I'm going to do. I'm literally going to slide the rotor on. Okay, kind of adjust the length. I'm going to tighten the screws by hand. Okay, I'm going to take my drill, and I'm going to have my drill on low speed. So it's about 360 RPMs. I don't have to go all the way. Right. This is how fast the testing of your generator output can be using this particular generator. Okay, and again, here we've got the two bearings are on one side, and that works fine for this generator. You could literally set it up this way, do something out here. You could have a second rotor. You could have a second generator mounted right here. It's a very nice setup. So there it is, and you notice the nice clean waveform. Very nice, very nice. Okay, so I can use this simple setup to test different magnets, and so I could use a blank. I could just be careful with these magnets. I could have a blank 4-inch plate, and I could put different magnets on it. Now I happen to, so these are rotors from other generators that we built in the past when we didn't know everything that we needed to know, I guess, about making generators. And I'm being very careful with this because the neo magnets want to grab and jump around the corner. Okay, so this is the setup here, and I'll tell you this, I've never done this, so this is really first time we've done this. So again, slide the the rotor on, and I'm probably going to need a Phillips screwdriver for this one. Okay, you're timing me? How fast does it take to do another test on this generator? It's amazing stuff, I'll tell you. This has been a good design. Jerry Bernardini did it. Dan Bartman was our practical person who talked to us about magnets and coils, which is part of the picture we never really understood well. But Dan builds many he makes homemade generators all around the world, and talks to people about doing it, and teaches them how to do it. And so he's got a lot of practical experience, which we're going to use for this actual competitive machine. Again, I've never done this before, so I don't know if we're going to get the results. Okay, so not a good looking rotor. Okay, not a good looking rotor at all. I can see the pictures there. Okay, yeah, kind of, but right. Much lower output voltage, and we noticed that the magnets are traveling much too close to the center of the generator. So let's take that rotor off. And so you don't really have to tighten things very tightly. You gotta be careful. So these magnets, I think I'm probably going to take them off of this and reuse them someplace else. Neodymium magnets are expensive, and so and they're hard to work with. So you got to be careful. The other, and again, I've never done this before. This is all brand new stuff. So again, here's some magnets I just stuck on a plate. Again, you can see the orientation. Okay, now this is a kind of interesting stator. It was built by somebody that wanted to make three-phase power, but Dan said that's not a practical setup for three-phase. So I just put them all together, and we're using it as a single-phase generator. Okay. Again, I haven't. Okay, there it goes. Okay, again, these plastic screws are nice, and that you can just tighten them by hand. Okay. So you got to make the basic parts. This rotor setup is key. You can actually use, if you notice, you can actually use a 5-inch metal disc. This is a 4-inch, and if I look at this, it looks like it really wants a 5-inch rotor, and that's what Dan told me. Dan told me I should probably be running a 5-inch, but we've got a lot of 4-inch plates, and so anyway. Okay, we ready to go? Okay, the output's real low. You can see one kind of funky waveform there. You kind of have a sine wave, and then you get something kind of funky. Alright, and again, I'm going back to what Dan told me, and again, this is something I've learned, and so what Dan said is that you really need space. You need space between your coils, so that when the magnet goes across the coil, you get that transition waveform. It goes positive. It's got to go back to zero, and then it's got to go negative on the next coil. And so if your coils are real close together, you start to get something probably like what we're seeing. Again, I've never looked at this at a scope before, but so there's another configuration we can try. And again, I haven't done this before, but I'm just going to try it right now. Okay, and these are the magnets that are most affordable, easiest to work with, and can again, you can learn about these. Now, if you're going to actually run this as a generator, you have to glue everything down, but we're not gluing anything down. North, south, north, south. Okay. I'm just having a lot of fun here learning about this. I just came up with a new idea I'm going to try. So let's try this. This is well, it looks like about the same. I still got that funky little spot right there. I don't know why. Okay. And 1, 2, 2.5. 2.5. Looks like we had about 2.5 volts. This is a 1 volt range. It's about 2.5 volts. Okay. And not really bad, but again, let's try. I got another idea. Let me try one more thing. Okay, 2.5 volts. I'm going to do a couple of quick variations on the theme. I'm going to take careful with the magnets. Just a north-south. One set of magnets. So now, okay, we're gonna have a little. Whoa! Okay, did I just learn something? That's crazy. Unexpected. So, and again, if you didn't have the scope, your voltmeter would be telling you that this is a much better setup than the other setup. Okay, so if that was good, maybe we got to try just two neo magnets. Okay. Again, how much time are we spending doing this? Not a heck of a lot of time. How much are we learning? I'll tell you, we're learning a lot. And in the past, I would have tried to write this all down, but I think this is really teaching me and probably anybody that wants to watch it a lot more. Holy cow, we're off the charts now. So, okay, so on my scope, I gotta. Okay, so that's 10 volts per division. So I'm seeing about more than 10 volts. Okay, and again, the distance from the magnets to the rotor make a difference. Okay, I'm going to just go down one range. Vertical scale at the limit. Okay, I got to go down 2 volts. Okay, 2, 4, 6, 8. About 9 volts peak to peak. Okay, what I'm taking away from this is that a better setup for this generator is just 2 magnets in this coil system. Okay. All right. So what do we learn from this? We learned that coils and magnets have to match in some way, and the only way you're going to know that, if you're not a well-trained engineer in magnets and in generator, is to just do some testing. Just do some testing, and this setup is so simple to use. We did some really quick tests. You know, we can do a lot of different what ifs here. We can, you know, I have so many different magnets. I can just sit here and play with magnets and figure out, oh, this is the best setup for this set of coils. Okay, it won't work on another set of coils, right? And if you don't have a set of coils, okay, Dan's got another step, and so this is the other idea, right? So you take and you mount your magnets here. So I've got magnets, I don't have coils. And in fact, what you do is you run the generator, and you could just use a blank starter plate. Maybe I'm going to do that next, okay? And we'll test some coils. That sounds like a great idea. Let's do that next.